A nuclear dawn, the promise and peril of Chernobyl. The Chernobyl nuclear power plant near Pripyat in the Ukrainian SSR symbolized Soviet progress and technological prowess. It was a beacon of the Soviet Union's ambition to harness nuclear energy for peaceful purposes, showcasing their technological advancements to the world. With its 4 RBMK-1000 reactors, it was meant to illuminate homes and power industries. These reactors were designed to be powerful and efficient, providing a significant portion of the region's electricity. However, hidden dangers in the reactor's design and operation awaited to unleash a catastrophe. The complexity of the reactor systems masked critical vulnerabilities that were not fully understood or addressed. The RBMK reactor was unstable at low power levels, a critical factor in the disaster. This instability made it difficult to control the reactor under certain conditions, increasing the risk of an accident. It also lacked a containment structure, allowing radioactive materials to spread unchecked. This absence of a crucial safety feature meant that any release of radiation could have devastating consequences. The combination of design flaws and operational shortcomings created a volatile environment. These issues were compounded by a lack of proper safety protocols and insufficient training for the plant's operators. The Soviet culture of secrecy and rigid hierarchy exacerbated the risks. Information about the reactor's flaws was not widely shared, and decisions were often made without input from those with technical expertise. Engineers faced pressure to prioritize production over safety, setting the stage for the tragic events of April 26, 1986. The drive to meet quotas and demonstrate the plant's success often overshadowed concerns about potential hazards. Chernobyl is a cautionary tale about the importance of transparency, accountability, and safety in technological advancement. It serves as a stark reminder that progress must be balanced with a commitment to safeguarding human lives and the environment.
The reactor's genesis, design, and early operations. The RBMK reactor, designed to produce both plutonium and electricity, was a marvel of Soviet engineering. It used graphite as a moderator and water as a coolant, a combination that was innovative yet risky. This design allowed for continuous refueling, which was a significant advantage, but it also introduced instabilities that were not fully understood at the time. Construction of the Chernobyl plant began in the late 1970s, a period marked by rapid industrial expansion and ambitious Soviet projects. The first reactor went online in 1977, followed by 3 more reactors in quick succession, making the plant one of the largest of its kind. The plant quickly became a vital source of electricity for the region, powering homes, industries, and contributing to the Soviet Union's energy grid. Despite initial success in the plant's critical role, concerns about the RBMK design lingered among scientists and engineers. The reactor's positive void coefficient posed a significant safety risk, leading to a potential runaway chain reaction if not properly managed. The Soviet authorities, however, downplayed these concerns, prioritizing production targets and maintaining the image of a flawless nuclear program, often at the expense of safety.
Seeds of disaster, systemic flaws, and operational oversights. The Chernobyl disaster was the culmination of systemic flaws and operational oversights that had been ignored for years. The RBMK reactor's instability and lack of essential safety features created a perilous environment, making it a ticking time bomb. Operating procedures at Chernobyl were riddled with shortcomings and inconsistencies, further exacerbating the risks. Operators often lacked sufficient training and a deep understanding of the reactor's complex behavior, leading to critical errors. Safety protocols were frequently disregarded in the relentless pursuit to meet production quotas, compromising overall safety. The Soviet Union's centralized structure severely restricted the flow of information, preventing critical safety issues from being addressed in a timely manner. The Chernobyl disaster serves as a grim reminder of the importance of a robust safety culture and the dire consequences of neglecting it. The blatant disregard for safety protocols, combined with inherent design flaws and systemic issues, ultimately led to the catastrophic events of April 26, 1986, forever changing the course of nuclear safety.
The fatal test, a cascade of errors. On the night of April 25, 1986, a routine safety test was scheduled at Chernobyl's Unit 4 reactor. The test aimed to assess the reactor's ability to cool itself using residual steam. Due to operator error and the reactor's instability, the power level dropped far lower than intended. This placed the reactor in a highly unstable state. Attempts to restore power led to uncontrollable increases in reactivity. Emergency shutdown procedures were ineffective due to design flaws in the control rods. The reactor experienced a sudden power surge, leading to explosions that spewed radioactive materials into the atmosphere. The Chernobyl disaster had begun.
The unthinkable unfolds, the explosion and immediate aftermath. The initial explosion at Chernobyl's Unit 4 reactor was followed by a second, more powerful blast. The force blew the steel and concrete lid off the reactor, exposing the burning graphite core. Firefighters rushed to the scene, unaware of the lethal radiation. Many first responders succumbed to radiation sickness. The Soviet authorities initially downplayed the disaster's severity. The evacuation of Pripyat was delayed for 36 hours, exposing residents to unnecessary radiation. The Chernobyl exclusion zone became a ghost town, a stark reminder of the nuclear disaster.
A silent killer. The invisible threat of radiation. Radiation made the Chernobyl disaster particularly terrifying. The silent killer contaminated air, water and soil. Health concerns include increased risk of cancer, particularly thyroid cancer, leukemia, and other blood disorders. Children and young adults are particularly vulnerable. The disaster led to a significant increase in thyroid cancer cases among children. The psychological impact was profound, with fear and uncertainty creating a lasting burden. The trauma of evacuation and loss of homes left deep scars. The lessons from Chernobyl have shaped radiation protection protocols and emergency response plans worldwide.
Nature's Reclaim. The ghost city of Pripyat and the surrounding exclusion zone. Pripyat, once a bustling city, became a ghost town after the disaster. Abandoned in haste, the city stands frozen in time. The surrounding exclusion zone became a desolate landscape reclaimed by nature. Wildlife flourished in the absence of human interference. Despite the absence of human habitation, the exclusion zone remains a place of ongoing scientific research. Scientists study the long-term effects of radiation on the environment. The zone provides a unique opportunity to understand ecological recovery.
Medical fallout, the human cost of Chernobyl. The human cost of the disaster is immense and continues to unfold. Radiation exposure claimed the lives of many first responders. Long-term health consequences include increased risk of cancer and other disorders. Children and young adults are particularly vulnerable. The psychological impact is significant, with fear and uncertainty creating a lasting burden. The trauma of evacuation and loss of homes left deep scars. The disaster highlighted the importance of providing comprehensive medical care and psychological support.
Shifting perspectives, the evolution of nuclear safety protocols. The Chernobyl disaster prompted a reassessment of safety protocols and reactor designs. The accident exposed critical weaknesses in the RBMK reactor design. The International Atomic Energy Agency played a crucial role in developing new safety standards. The disaster spurred the development of more stringent safety regulations. New reactor designs emphasize passive safety features to minimize human error. The Chernobyl disaster marked a turning point in the history of nuclear power. The accident forced the world to confront the potential consequences of nuclear technology.
Legacy of loss, lessons learned, Chernobyl's enduring impact. The Chernobyl disaster left an indelible mark on the world. The accident resulted in the loss of lives, displacement of communities, and contamination of land. The legacy of Chernobyl continues to shape our understanding of nuclear safety. The disaster highlighted the interconnectedness of the world. The international response underscored the need for global cooperation in nuclear safety. Chernobyl also served as a catalyst for greater transparency and accountability in the nuclear industry. The legacy of Chernobyl is one of loss, resilience, and a renewed commitment to safety. A somber reflection, remembering Chernobyl, shaping the future. 38 years after the disaster, the world continues to grapple with its consequences. Pripyat stands as a haunting monument to the tragedy. The exclusion zone serves as a living laboratory for studying radiation's long-term effects. The lessons from Chernobyl have shaped nuclear safety protocols worldwide. The disaster highlighted the importance of containment structures, operator training, and emergency preparedness. Chernobyl underscores the ethical considerations surrounding nuclear technology. As we reflect on the anniversary, let us remember the victims, acknowledge the lessons learned, and renew our commitment to responsible technological development.